In this lesson, we will focus on multiplying and dividing two numbers in scientific notation. Our objective for this lesson is the learner will be able to perform multiplication and division of numbers in scientific notation. In multiplying or dividing numbers in scientific notation, keep in mind that it is very important to know the different laws of exponents. So the first law of exponent that you should know is the product of a power. It is in this pattern. If a times 10 to the power of m times this parenthesis here means multiplication times b times 10 to the power of n, then for this first scientific notation, your first factor is a. And for the second scientific notation, we have b times 10 to the power of n. Your first factor is b. What are you going to do is you need to multiply the first factors. So that is a multiplied by b. So we have here a times b. And then for the second factors, we have 10 to the power of m for the first scientific notation. And for the second scientific notation, that is 10 to the power of n. So we have here 10 to the power of m multiplied by 10 to the power of n. We need to add its exponents. So that is 10 to the power of m plus n, where your a, your b, and your m and n are real numbers. So simple. When you multiply two scientific notations, you need to multiply the first factors and then copy the base of the second factor, which is 10, and just add the exponents. Another important law of exponent that you should learn is the quotient of a power. It is in this pattern. If a times 10 to the power of m divided by b times 10 to the power of n, then your first scientific notation here is a times 10 to the power of m, and your second scientific notation is b times 10 to the power of n. And take note, the operation here is division. So first thing that you should do is you will divide the first factors. So the first factor here is a, and then divided by the first factor of the second scientific notation, b. So that's why we have a divided by b, and then divided by the second factor here is 10 to the power of m. For this one, we have 10 to the power of n. So that is 10 to the power of m divided by 10 to the power of n. So we will subtract its exponents. So that is m minus n. So we will subtract the exponents when dividing numbers with the same bases. And then take note, it should be that a, b, m, and n are real numbers. Let's now apply the different laws of exponents in multiplying and dividing numbers in scientific notation. Let's begin with the multiplication of numbers written in scientific notation. Here is now our first illustrative example. 2.3 times 10 to the power of 7 multiplied by 3 times 10 to the power of 4. Take note that this parenthesis here means multiplication. So, we can apply the law of exponent that we discussed a while ago, which is the product of a power. It is in this pattern, a to the power of n multiplied by a to the power of m is just equal to a, we'll copy the base which is a, and then add the exponents n plus m. Let's try it. So our first factor for the first scientific notation here is 2.3. And for the second scientific notation, our first factor is 3. So what are you going to do is you will multiply the first factors. So we have here 2.3 times 3 multiplied by, for the second factor, this is now 10 to the power of 7 and 10 to the power of 4. So we have here the same bases. So we will add 7 and 4. We will now apply the product of a power. What will be the result? If we will multiply now 2.3 times 3, that will give us an answer of 6.9. And then we will add the exponents 7 plus 4. That will give us an answer of 11. So this is now in the scientific notation. This is now our final answer. 6.9 times 10 to the power of 11. Let's have now illustrative example number 2. The given is 1.21 times 10 to the power of 10 divided by 1.1 times 10 to the power of 7. Take note that our operation here is division. So we can apply the quotient of a power, which is in this pattern a to the power of n divided by a to the power of m. So take note that for the quotient of a power, when you divide numbers with the same bases, we'll just copy the base and then subtract its exponents. So that is why we have n minus m. Let's now apply this in solving this given expression. So our first factor for the first scientific notation is 1.21. For the second scientific notation, 1.1. So we will divide 1.21 divided by 1.1. And then for the second factors, we will divide also 10 to the power of 10 divided by 10 to the power of 7. So that is 10 to the power of 10 divided by 10 to the power of 7. Simplifying, so we have here 1.21 divided by 1.1, and then this part here, we will now apply the quotient of a power. So we will subtract 10 minus 7. So that will give us an answer of 10 minus 7 is 3. And where did we get 1.1? We divided 1.21 divided by 1.1. So therefore, we have now the answer 1.1 times 10 to the power of 3. Let's have now the illustrative example number 3. The given is 3 times 10 to the power of negative 5 multiplied by 2 times 10 to the power of 7. Take note that the parenthesis here means multiplication. So we can apply the product of a power, wherein the powers of our second factors, we will just add. So we have here, again, same with the previous examples, we will just multiply the first factors, 3 times 2. So we have here 3 times 2. And for the second factors, we have 10 to the power of negative 5 multiplied by 10 to the power of 7. Simplifying, 3 times 2 is just equal to 6. And then 10 to the power of negative 5 plus 7. We apply here the product of a power wherein it states that when the two numbers have the same basis, then you can, in multiplying it, you can just add the exponents. Simplifying further, the answer here is 6 times 10 to the power of negative 5 plus 7. Take note that when adding different signed numbers, you will subtract it and follow the sign of the numbers or of the number that is farther from 0. So which is farther from 0? Is it 7 or negative 5? Of course, it's 7. So 7 is positive. That is why we have 2 as the answer. So we have here the final answer, 6 times 10 to the power of 2. Illustrative example number 4. The given is 8 times 10 to the power of 5 times 7 times 10 to the power of 6. Take note that this parenthesis here means multiplication. So we can apply the product of a power. Simplifying, just like the other previous examples, we will just multiply the first factors. So that will give us 8 times 7. And then the second factor is 10 to the power of 5 multiplied by 10 to the power of 6. Simplifying further, we have 8 times 7 is equal to 56. And then for this part here, we'll just copy these bases. So that's 10. And then add 5 plus 6 based on the product of a power wherein we will just add the exponents. So we have here the result, 56 times 10 to the power of 11. But observe that our first factor here, 56, does not satisfy the requirement for our A in writing the scientific notation. Remember that our A should be greater than 1 or equal to 1 but less than 10. So in this case, this 56 here is greater than 10. So we will find ways on how to make this 56 satisfy the condition for A. So it should be less than 10. Greater than 1 or equal to 1 but less than 10. So remember in our previous video tutorial that if you are going to move the decimal place or the decimal point, it will change its exponent or the exponent of your second factor, which is 10. Okay, so let's try this one. 56. To make this one satisfy the condition, remember that 56, it's understood that the decimal point is after 6. So we can move it to the left and transfer the decimal point here so that it will satisfy the condition. So that will give us 5.6. Yeah, we have moved it to the left. So it means that the decimal or the power of our 10 will become bigger. So that is 5.6. We move only once. So times 10 to the power of 1 times 10 to the power of 11. So that will give us 5.6 times 1 plus 11, applying the product of a power. So 1 plus 11 is equal to 12. So we have now the final answer, which is 5.6 times 10 to the power of 12. Illustrative example number 5. The given here is 9 times 10 to the power of 4 multiplied by 6 times 10 to the power of negative 7. So the operation here is multiplication. Thus, we can use the law of exponent, which is the product of a power. Simplifying, we will just multiply the first factors, 9 times 6. And for the second factors, 10 to the power of 4 times 10 to the power of negative 7. Simplifying further, 9 times 6 is equal to 54. And then for our exponents here, we will apply the product of a power, wherein we will just copy the base and then add the exponents. Simplifying further, we have here 54 times 10 to the power of 4 plus negative 7. Take note that we are adding different signed numbers. In adding different signed numbers, we will just subtract it and follow the sign of the number farther from 0 in the number line. So we will just subtract 7 minus 4, that is equal to 3. And take note that negative 7 is farther from 0 compared to 4. So we will follow the sign, which is negative. So that is why it's negative 3. However, take note of our first factor here, it's 54. And remember in scientific notation that our first factor should be greater than or equal to 1 but less than 10. In our case here, 54 is greater than 10. That does not satisfy our condition. So we'll find ways on how to make this greater than 1 or equal to 1 but less than 10. So we have here 54, it's understood we have decimal point after 4. So we can move it to the left once so that we have 5.4 times 10 to the power of 1. Why is it 10 to the power of 1? Because we move only once to the left, and when we move it to the left, the power of your 10 here will become bigger. So that is why times 10 to the power of 1, because we move only once, times copy 10 to the power of negative 3. So in this part, we can also apply the product of a power, that is 10 to the power of 1 plus negative 3. So that will give us the result of copy 5.4 times 10. We have 1 plus negative 3. Still, we are adding numbers with different signs. So we'll just subtract 3 minus 1 is equal to 2 and follow the sign which is farther from 0 in the number line. Which is farther? Is it 1 or negative 3? Of course, it's negative 3. So we'll follow the negative sign. So our final answer here is 5.4 times 10 to the power of negative 2. Illustrative example number 6. 9.3 times 10 to the power of negative 5 divided by 3 times 10 to the power of 7. Take note that the operation here is division, so we can apply the quotient of a power. So simplifying, we have the first factor here, 9.3, divided by the first factor of the second scientific notation, 3. So that is 9.3 divided by 3 is equal to 3.1. For this part here, 10 to the power of negative 5 divided by 10 to the power of 7, we will apply the quotient of a power. So that is 10, copy the common bases, so 10, and then subtract the exponents, so that is negative 5 minus 7, and then simplifying 3.1 times 10 to the power of negative 12. Why is it equal to negative 12? Because when we subtract negative 5 minus 7, we will follow the rules in subtracting integers. So we'll just copy the minuend and then proceed to addition and change the sign of our subtrahend. So that is 7, positive 7 will become negative 7. So here, we are now adding numbers with the same signs. So that is negative 5 plus negative 7 is equal to negative 12. So that is why we have the answer 3.1 times 10 to the power of negative 12. So this is now our final answer.